All right, so for example, let's take a look at this problem. Here we've got a graphed linear function or equation, and we want to find the slope. So first what we want to do is we want to look carefully along the line, and we want to find some points where the line intersects the grid lines of the graph paper fairly precisely. Like for example, right here. I'm going to mark that spot. See how the graph paper and the line itself are just kind of all on top of each other. All right, here's another one right here. Okay, and if I keep going across, you can see that little leapfrog pattern that I can jump from dot to dot, and as long as I do it in a consistent manner, I get the slope. Okay, so let's start from where I was here. So here, as far as rise and run, looks like I went down 1, and then over 1, 2, 3, 4 to the right. Okay, so as far as rise goes, I'm going to put this down here. When I look at the rise, that if I rise upwards, it's positive, and I rise negatively downwards. I know rise usually means up, but in our case, rise could mean up or down. Okay, but if I do have to go up, it's positive. If I go down, it's negative. So in this case, this would be a -1 because I went down 1 space, and then 1, 2, 3, 4 to the right. And if you think about a normal number line, a typical number line, running across is typically just like a number line. If I'm running to the right, it's positive. If I run to the left, that's negative. So in this case, I'm going to the right, it's +4. So when I put this in rise over run form, the rise is -1, the run is 4. And so this specific angle, this direction that this line is traveling, is assigned the number -1/4. All right. All right, here's another example. So what we do is we find our line. We find some key points along it. There's one that's already marked for us. And then we find the slope. All right, so again, let's take a look at the idea of rise and run. So let's say I want to go from this point to this one. I would rise actually downwards, so that'd be 2 negative because I'm going down. And then to the right, 1, 2, 3 spaces, and to the right is +3. So my slope here would be -2/3. So any line like this one that traveled in the exact same angle or direction would also have a slope of -2/3. Now, it's at this point which we usually get this question. Well, what if we went the other direction? What if we had started at this point? Let me change pen color here. Started at this point and then went up to this one. Which way is the correct way to go? Well, the nice thing is it doesn't matter. And this is the other reason that slope is written as a ratio or a fraction, is because mathematically it all still works out. Let's say we did that. Let's say we started here and then went to this one instead. Okay, well that would mean the rise would then be up 2 spaces, so +2, and then back to the left 3 spaces. So I'm going to the left, that'd be -3. So in that case, I would get a slope of +2 over -3. Okay, but see how either way we do it, we still get -2/3 for our answer. It doesn't matter that the negative's here. In fact, we could clean this up even further and call this a slope of negative out in front, 2/3. Okay, so which way do you go? Do you go left to right or right to left? The nice thing is it doesn't matter, that either way you should get the same answer for your slope. All right, here's another question that comes up. What if you miss a point? What if you're sitting here and you start picking your points, like this one, and then this one, and that one, and you miss a point? Will that affect your answer? Well, again, nice thing is no. All right, let's say I pick these first two. In this case, I would use this one. I'd have to rise 1 and run to the right 3. So +1, +3, so I'd get a slope of 1/3. Okay, but what if I accidentally skipped over this point and I had been using, let's again change pen color here. Let's say I had graphed this point, accidentally missed that one, and pick this point. Okay, in which case my answer here would be I have to rise 2 and then run across 1, 2, 3, 4, 5, 6. So in that case, my slope would be a rise of 2 and a run of 6. But because slope is written as a fraction, and we always reduce our fractions, 2/6 still reduces down to 1/3. All right. So if you miss a point, no big deal. Okay. And if you go, different direction, it doesn't matter. And that's the nice thing about slope. It doesn't matter if you go left to right or right to left. It doesn't matter if you hopscotch over one of the points, that it will always simplify down to the same answer regardless of which way you do it. Okay?